Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my YouTube channel. And um, today, in this video, we're going to discuss the non-covalent interaction analysis, which is famously called as NCI analysis. So this is a continuation of the series of the videos I made earlier for the non-covalent interactions. And in this video, we'll learn how to draw these kind of graphs that are shown like this one or these images which are present in different research articles, and that these images show you discuss different things about the non-covalent interactions, and they generally include or indicate the areas of hydrogen bonding, van der Waals interactions, and repulsive interactions between the molecules. So this is the manual of this software Multiwfn, which has a very detailed understanding of everything. And I have opened the section about the non-covalent interactions analysis. If you want, you can give it a read and you can understand more things. But I just wanted to show you this uh, colored bar where different areas show or different colors show different kind of interactions. And this is also present in the example folder of Multiwfn. And you can simply download it from here and use it in your publications. Or and then you can describe it in the caption what different colors represent here. So without any more wait, let's move to doing the analysis. And I will do a very simple molecule that is a water cluster. I have optimized 3 different water molecules that are hydrogen bonded to each other. And we'll start with this molecule and go through all the steps. So then we can maybe try an example on a complex molecule later on. So first of all, open Multiwfn, and then I will drag this fcheckpoint file of the water cluster into Multiwfn. You can see that it is here. And now if I press enter, it will give me the menu. So the first thing is I need to select option number 20, that is visual study of weak interactions. I write 20, press enter, and then we go for the NCI analysis, which is also called the RDG analysis, and it has been described in this Jack's paper. So 1, enter, and then you can select the grid, low quality, medium, and high quality. So it's your choice. If you want a high quality grid, it will take a little more time. So I'll just continue with the medium one, number 2. And then what we want is we want to output the scatter points of this analysis to a file called output.txt in the current folder. So I'll write 2 and press enter. So you'll see a file output.txt appeared here. And then we will also need to save the function1 and function2 cube files that we can visualize in VMD later on. So I'll press 3 and press enter. So you see you have got function1 and function2.cube files as well. So now if you want, you just write 7 and press enter. And then you input the value of isosurface. It's just the size of the isosurface. If you write 0.5, it's a bit small. And if you write 1, it's a bit bigger. So now you see you can visualize the isosurface here, and which is good, but it's not easy to rotate. You have to click these buttons, and then you can save an image file as well if you want. So we'll not do this step in Multiwfn, rather we do this step in VMD, because VMD is a very powerful and free software tool for this kind of things. So I'll just minimize this, and what we will do is we'll open the VMD folder that is supplied in the Multiwfn folder. And before that, we just want to move these two functions .cube files to VMD folder. And then you should already have this file called rdgfill.vmd. If it is not there, then you should go to the multiwfn folder and examples, and then find here rdgfill.vmd, copy it, and then paste it in VMD folder. So when it's there, just open the VMD. So VMD is here, and what we'll do now is, I'll just make it a bit bigger. Now we need to load the file in VMD. So we'll just use the script called the rdgfill.vmd. So we'll go File, Load Visualization State, and then we are in VMD folder. I'll select the rdgfill.vmd and click Open. So you see here is the molecule, and you can see the interactions, RDG surfaces among the molecules. So then you can, so these colors are the same colors that are described in that image which I showed you here, and you can use this this color bar for interpreting these colored images. And if you want to do any more settings, you can with VMD. And when you need to export this image, you can go to File and Render. Then here we'll select the tachyon internal memory rendering. And here you can just say dash format PNG, and here write that name of the file, like watercluster.png, and then you click Start Rendering. So you'll see the file will appear here if I start rendering. So it will appear in the VMD folder, and if you open it, you can see the molecule here. And you know that if you right click it in Windows now and edit with photos, so you can crop it, and yeah, so we can crop the extra area from it and just save. So you've got the NCI image for this molecule. And now if you want to also obtain the 2D graph for this, we can do that. Let's do it. So if you want to make a 2D graph like this, where you can discuss different kinds of forces, and for that, I will advise that first we download this EPS viewer, because the files can be opened by this EPS viewer, and then we can save a JPEG or PNG, whatever we want. So if you write in Google download EPS viewer and can click this one and download the EPS viewer from here, so it will just start the downloads. And then if you double click that downloaded file and click next, next, and finish, and you'll get the EPS viewer installed. Because I have already installed it, so I'm not going to do this step, but it's really simple. You just click it and you need to click next, next, and then finish. So we'll close the VMD, and now we come to the Gnuplot for plotting these kind of graphs. So for that, you need this output.txt file that you generated. So if I copy it and Oh, actually, that was something else. So this is the output.txt file we just generated. We copy and go to Gnuplot folder. And because it's a Windows version, so I'll run it from the bin. And it's better that you copy that file here. It would be easier for the script to plot it. So I'll just delete this file so you know that it is newly generated. So now we have the output.txt file here, and we have this script rdgscatter.gnu. If that script is not present, you can again find it in the Multiwfn examples folder and copy it here. So what I'll do is I'll open this Windows version of Gnuplot. So this is a graphical Gnuplot. If you want, you can also use the command line one. On command line, you'll just call Gnuplot and then name of this script, and it will do the rest of the job. So if you go to File, Open, and All Files, and we'll find this script, rdgscatter.gnu. This script has the name of the output file, output.txt, and it will take this file and plot it in such a format. So if you just click Open, you'll see that it has produced a file called rdgscatter.ps. So this is a PostScript file which will be opened by the EPS viewer. That's why we installed the EPS viewer. So if you double click it, it will just open the file in EPS viewer. Don't worry for it. It's rotated. We can straighten it. So in EPS viewer, you can increase the resolution of this image. So I'll just go for 1000 by 1415. And then you can save the file in wherever you want. So water cluster under RDG. And you can select JPEG, PNG, or whatever format you want. So I'll select JPEG at the moment. Click Save. Now your file is saved in Downloads folder. So if I open the Downloads folder, here is the file. I'll open it again, go to Photos, Edit with Photos. And here you can resize it. I mean, cut the extra white area, and then you can also rotate it, and then you go Save Option and save. So now if you see, you have got this graph as well, and you can describe the interactions by studying literature, or it's more about studying and practice. Like you can identify different areas. Where are the hydrogen bonds? Where are the van der Waals interactions? And where are the steric effects? So it's mostly, you can see that the hydrogen bonding is present in water molecules. So you are seeing these dots in this area. Similarly, you can do the NCI analysis with other complex molecules and obtain the RDG scatter plots and the NCI plots with these tools that you can use easily in your publications, and then uh, explain the kinds of interactions. So that was all about the NCI analysis using Multiwfn VMD Gnuplot. And if you got any questions, you can post in the comment section, and I'll try to address them as soon as possible. And we'll try to study a little more complex molecule in the next video. Until then, I'll leave you here, and we'll see you in the next video. Thank you very much for watching. Bye bye.